Good morning, students. This is SS3 Further Maths class. Today's date is 20 May 2020. We are starting the topic of partial fraction. Partial fraction. What is partial fraction? Partial fraction is the product of breaking down a single algebraic fraction into two or more simpler fractions. You will recall that in your general maths class, you simplified two or more algebraic fractions into a single fraction. E.g., simplify 3 over x plus 1 plus 4 over x plus 5 into a single fraction. Solution 3 over x plus 1 plus 4 over x plus 5 is equals to, draw the line of division, is equals to what? Now, the first thing you do here is to find the LCM. The LCM of x plus 1 and x plus 5 is x plus 1 into x plus 5. X plus 1 into this LCM. In other words, this LCM divided by x plus 1, you get x plus 5. Use this x plus 5 to multiply the numerator 3. That is 3 times x plus 5. You get 3 into x plus 5 plus x plus 5 into the LCM. X plus 1 into x plus 5. You get x plus 1 times 4. You have 4 into x plus 1. The next step now is to expand the numerator. Expanding the numerator, you have 3 times x, 3x. 3 times 5, 15. 4 times x, 4x. 4 times 1 plus 4 over x plus 1 into x plus 5. Add the numerators, add the like terms of the numerator. So this will give you 3x plus 4x, 7x plus 15 plus 4, 19 over x plus 1 into x plus 5. Now, our answer is 7x plus 19 over x plus 1 into x plus 5. This is our answer. So the process of combining two algebraic fractions to this single fraction has given us 7x plus 19 over x plus 1 into x plus 5. Now, the process of breaking this single fraction in order to get back at the two algebraic fractions given to us is what we call the partial fraction. So, the partial fraction is the reverse process of the composition of two or more algebraic fractions into single fraction. The reverse process of breaking the process of breaking down a single algebraic fraction into two or more simpler fraction is called partial fraction. For instance, in the case of the first example, that is adding two algebraic fractions to obtain a single fraction, we can break down this single fraction and we get back to the two fractions given. Example. Example 1. Resolve 7x plus 19 over x plus 1 into x plus 5 into partial fraction into partial fractions. Into partial fractions. Solution. Let 7x plus 19 over 7x plus 19 over x plus 1 into x plus 5 be equivalent to a over x plus 1 plus b over x plus 5, where a and b are constants to be determined. Here we clear the fraction. By multiplying through by multiplying through by the LCM, i.e. multiply equation 1 through by the denominator. Of the left hand side of equation 1. If you do that, we have 7x plus 19 is equivalent to a into x plus 5 plus b into x plus 1. Call this equation 2. The next step now is to determine the constants a and b. How do you determine the constant a and b? You choose a value of x that will eliminate a constant at a time. For instance, if you want to eliminate constant b in equation 2, you take x to be minus 1. Put x equals minus 1 in equation 2. If you put x equals minus 1 in equation 2, you have 7 into minus 1 plus 19 is equivalent to a into minus 1 plus 5 plus b into minus 1 plus 1. You know minus 1 plus 1 will give you 0. So I'm left with minus 7 plus 19 is equivalent to a into minus 1 plus 5 is 4 plus b into minus 1 plus 1 is 0. 19 minus 7. That's minus 7 plus 19 is 12. 12 is equals to 4a plus 0, or 4a equals 12. If 4a equals 12, you have a equals 12 over 4, which is 3. Now, put x equals minus 5 in equation 2. Put x equals minus 5. Why are we assigning minus 5 to x? Because in equation 2, when x is minus 5 plus 5, you have 0. So 0 times a is 0. So by so doing, a is eliminated. Then you solve for b. That is why we are looking for a value of x that will eliminate that constant a. And the only value of x that will eliminate that constant a is minus 5. because it is minus 5. When you add minus 5 to plus 5, you get 0. So 0 times a is 0. So by so doing, a is eliminated. Put x equals minus 5 in equation 2. If you do that, I have 7 into minus 5. That is, in the left hand side, 7 into minus 5 plus 19 is equals to a into minus 5, a into minus 5 plus 5 plus b into minus 5 plus 1. 7 times minus 5 is minus 35 plus 19 is equals to minus 5 plus 5 is a into 0 plus b into minus 4, because minus 5 plus 1 is minus 4. Minus 35 plus 6 plus 19 is 16. Therefore, minus 16 is equal to 0 minus 4b, or minus 4b is equals to minus 16. Therefore, b equals minus 16 over minus 4, which is 4. Now, the values of a and b are known. So I can now write my partial fraction. I can now write my partial fraction. 7x plus 19 over x plus 1 into x plus 5 is equivalent to a. And what is my a? 3 over x plus 1 plus b. What is my b? 4 over x plus 5. This is my partial fraction, which is the final answer. If you compare this result with the question given, you discover that you have 3 over x plus 1 plus 4 over x plus 5, which is exactly the same thing as the two fractions that we are asked to combine to give a single fraction. So this is why it is a reverse process. I'm done here.